Objective 2. Identify experiments in observational studies. Definition. An observational study measures the characteristic of a population by studying individuals in a sample, but does not attempt to manipulate or influence the variables of interest. The experimenter simply observes the results of the study or collects data in a survey. Observational studies do not allow a researcher to claim causation, only association. Definition. A designed experiment is a controlled study in which one or more treatments are applied to individuals in order to attempt to isolate effects of the treatments on a variable. Experiments allow a researcher to claim causation. Definition. In a study about whether a variable X affects a variable Y, we call X the explanatory variable, or we call it the independent variable. We call Y the response variable or the dependent variable. And one way to kind of read this is using the word ear. Explanatory affects the response. Example. Identify an experiment and an observational study. Identify whether the study is an experiment or an observational study. Discuss whether the components of a good study were used. 1. For 5 years, the author taught an innovative intermediate algebra course in which students learned by working in groups. Then the author compared the proportion of the successful intermediate algebra students who passed trigonometry with the proportion of other professors' successful intermediate algebra students who passed trigonometry. This is an observational study. The author performed an observational study because he did not determine which students enrolled in his intermediate algebra class, the treatment group, and which students enrolled in other intermediate algebra classes, the control group. The study has several good components. It has a treatment and control groups. A placebo is used in the sense that the control group still participated in an intermediate algebra course. The study is single blind because the students did not know they were in a study. Although the sample size is not stated, it is likely pretty large because the study lasted for 5 years. There are 3 problems with this study. First, the students were not randomly assigned to the treatment and control groups, so the 2 groups might not be similar. For example, if the author has a reputation for being challenging, weaker students may have avoided enrolling in his class. A second key problem is that the author may be better or worse at teaching than the professors teaching the control group. Finally, the study is not double-blind because the author knew that the students in his intermediate algebra courses were in the treatment group. Number 2. In a study to determine whether heart rate reduction lowers heart failure in mice, researchers randomly assigned 40 mice to a treatment group and 8 mice to a control group. The researchers injected the treatment group with a drug that lowered the mice's heart rate. The control group was injected with a placebo. Then the mice in both groups were injected with a drug that typically causes heart failure. The proportion of mice who experienced heart failure was recorded for both groups. This is what we call a designed experiment. The researchers performed an experiment because the researchers determined which mice were in the treatment and control groups. The study has many good components. There are treatment and control groups, a placebo was used, and there was a random assignment. The study is single blind because the mice were not aware of which group they were in. 2 components of the study are not clear. It is not stated whether the study is double blind, and it is not clear whether the sizes of the treatment and control groups are large enough. You will learn to evaluate such group sizes in a statistics course. Another example. Identifying components of a study. Otous media with effusion is a collection of non-infected fluid in the middle ear space, mostly affecting children between 6 months and 3 years of age. It often causes hearing difficulties, loss of balance, and delayed speech development. In a double-blind study, researchers tested whether the drug mometasone in nasal spray form is effective for treatment of OME. Hundreds of children between the ages of 2 and 12 years were randomly assigned to receive mometasone nasal spray or a saline nasal spray for 6 months. The study concluded that mometasone nasal spray is an effective treatment of OME. So for number 1, describe the treatment in the control groups. Well, number 1, the treatment group consists of the children in the study who were treated with mometasone. The control group consisted of the children in the study who received saline nasal spray. Number 2 is the study an experiment or an observational study. Well, the study is an experiment because the children were randomly assigned to the treatment and control groups. Number 3, describe the sample and the population. The sample consists of all the children in the treatment and control groups. The population consists of all children between the ages of 2 and 12 years who have OME. Number 4, what are the explanatory and response variables? The goal of the study was to determine whether mometasone is an effective treatment of OME. So, the variable of whether mometasone is used is the explanatory variable. And the variable of whether a patient is cured of OME is the response variable. What does it mean that the study is double-blind, and how could that be accomplished? Double-blind means that neither the individuals nor the researcher in touch with the individuals know which individuals are in which group. To accomplish this, one researcher could randomly assign the individuals to the treatment and control groups without telling the individuals. Then she could write the individuals' names on identical nasal spray containers and fill each container with either mometasone or saline solution according to the random assignment. And finally, another researcher who does not know the random assignment could give the containers to the individuals. Association versus causation. There is an association between the explanatory and response variables if the response variable changes as the explanatory variable changes. For example, there is an association between the number of firefighters who fight a fire, an explanatory variable, and the amount of fire damage that occurs, which is the response variable. After all, the more firefighters that fight a fire, the larger the fire tends to be, so there tends to be more damage. However, that does not mean that an increase in the number of firefighters causes more damage. A larger fire causes more damage in the presence of more firefighters. So take a look at figure 16. Larger fire, more firefighters, explanatory variable. Larger fire, more damage, response variable. So a larger fire causes more damage in presence of more firefighters. Now, if the change in the explanatory variable causes a change in the response variable, we say there is causality. When it comes to determine causality, experiments have a huge advantage over most observational study. Determining causality. A well-designed experiment can determine whether there is causality between the explanatory and response variables. Most observational studies cannot determine whether there is causality between the explanatory and response variables. They can only determine whether there is an association between the two variables. So, for example, are the following studies examples of an observation study or design experiment? Then determine if the researcher can claim causation or association. If it is an observational study, redesign the study so that it is a designed experiment. So for part A, researchers wanted to determine if having a television in the bedroom is linked with obesity. The researchers administered a questionnaire of 379 12-year-olds across the United States. After analyzing the results, the researchers determined that the body mass index, or BMI, of adolescents who had a television in their bedroom was significantly higher than that of adolescents who did not have a television in their bedroom. So this is an observational study, and therefore it's an association. The 379 12-year-olds, the treatment was having the TV in the room. The control group would be no TV in the room. Part B. A boss is curious to see whether caffeine helps with the productivity of his employees. The boss first measures the productivity of 12 of his employees for a week. Then he makes 10 of his employees drink 2 cups of coffee every day for a week and makes the other 10 employees drink decaffeinated coffee every day for a week and measures the productivity of all 20 of his employees. He then compares the differences in productivity. In this case, we have a designed experiment that would then have a causation. Example: a researcher wishes to test the effects of the drug ecstasy on a person's IQ. The researcher has 100 individuals and gives them all an IQ test. Then the researcher breaks up the 100 people into two groups. One group of 50 individuals is given the drug ecstasy, and after 5 hours is given another IQ test. He finds the difference in each individual IQ scores. For the second group of 50 individuals, they are given a placebo, and after 5 hours is given another IQ test. He finds the difference in each individual's IQ score. The IQ scores of those in the first group drop by 15 points. The researcher finds that ecstasy negatively affects a person's IQ. So for part A, describe the treatment and control groups. Well, the treatment is ecstasy. The control group would be the placebo. In part B, if this is an observational study or design experiment, explain if it is an observational study, redesign it so that it is a design experiment. Well, it's a design experiment since we are making our subjects take ecstasy. What are the explanatory and response variables? Well, the explanatory variable is the ecstasy, and the response variable is what are the IQ scores. And remember that explanatory affects response. In part D, what is the conclusion of the study? Does it have to do with causality or causation, or only association? Well, ecstasy negatively affects a person's IQ. So this is causation because we determined that it was a designed experiment. Example: researcher Penny Gordon Larson and her associates wanted to determine whether young couples who marry or cohabitate are more likely to gain weight than those who stay single. The researchers followed 8,000 men and women from 1995 through 2002 as they matured from the teens to young adults. When the study began, none of the participants were married or living with a romantic partner. By 2002, 14% of the participants were married and 16% were living with a romantic partner. At the end of the study, married or cohabitating women gained on average 9 pounds more than single women, and married or cohabitating men gained on average 6 pounds more than single men. So for part A, we want to describe the treatment in the control groups. Well, the treatment is married cohabitating. The control group are single people. Part B, is this an observational study or a design experiment? And then explain, if it is an observational study, redesign it so that it is a designed experiment. It's an observational study since we are only observing and collecting data. If we have 8,000 people, then we can say the treatment, make them get married or live with a partner. The control group would make them stay single. That would be the redesigning of the experiment. In part C, what are the explanatory and response variables? Well, the explanatory was the marry or cohabitate. The response variable is the weight gain. In part D, what is the conclusion of the study, and does it have to do with the causality or only association? Well, this is married cohabitating people gain more weight, so therefore this would be association.